Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to another edition, another week of Lost in Science. My name is Claire and this is 30 minutes of some of the most entertaining, some of the most insightful, obviously some of the best science that you are going to hear this week. And this week on the show, I am joined by Stu and Chris, as usual. Hello.
Ahoy, hoy.
Howdy.
Howdy. Howdy, Stu. How are you?
I'm pretty good. Good.
Yeah. And what have you got for us this week?
Well, I was reading some interesting commentary about metabolism this week, and there's been some interesting developments in the science around human metabolism, and basically that it kind of doesn't work how everyone assumed it worked. And that's mainly because nobody had ever tested the assumptions before.
Oh, so
they had done, a lot of people have done work around human metabolism, but there was this sort of overriding idea that, you're born, your metabolism is what you've got, and then as you get older, it's not as good.
Yeah, slows down.
And that was kind of the theory, and everyone went, well, I certainly feel older, so maybe that's true. But recently, they've actually collated a whole bunch of data from all over the world and gone, oh, well, no, it doesn't actually work exactly like that. There's a bit more to it than that, and it does actually shine some light on a bit of human activity and maybe, how things really work, and not just that, oh, I feel older than I was. But
right.
It may be nothing to do with our metabolism. But I'll explain exactly what I'm talking about in the story.
Well, fingers crossed, there's some good news for all of us that feel like we're getting a little bit older.
Well, you might take it as good news. You may not. It's entirely subjective.
Great. And Chris, what have you brought for us this week?
Well, so Lost in Science, we often cover like the science award season. We're a big fan of the award season. We've already talked about the Nobel Prizes and the Ig Nobel Prizes, of course.
Yeah.
I think we missed one of the local ones, the Eureka Awards.
Yeah, we missed the Archies.
Archies, yeah.
The Archies?
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 The Archies?
Named after Archimedes.
Named after, yeah.
Anyway, so they're awarded by Australian Museum. Of course, they are kind of one of the glamorous highlights on the local kind of awards calendar. But perhaps, the most prestigious local award, though, for the, if you want your boutique drop, I suppose, is the Prime Minister's Prize for Science. I know what you're thinking. The Prime Minister, what does he know about science? Oh, there's a bit of a dig there. But, no, this is like a prestigious award that is given out every year. And this year it was awarded to virologist Professor Eddie Holmes from the University of Sydney, who basically was the person who first publicly released the SARS-CoV-2 genome to the world.
Great!
So I thought I'd talk a bit about how all that happened, and also, give a bit of a shout out to the people who did the work in China.
I do remember us covering this story early on in the pandemic, that it was a collaboration between scientists across China and scientists in Sydney.
That's right. So I'll talk about that. Also give a bit of a look at how, even though he has just been recognised officially, kind of the highest level of Australian science for his opening up of this important knowledge, there are still conspiracy theorists claiming that he's covering it up.
Great. Well, stay tuned for those two awesome stories later in the show.
So yes, Professor Eddie Holmes from the University of Sydney has been awarded the Prime Minister's Prize for Science. As I said in the introduction, it is kind of considered the most prestigious local award, as in Australian award for science. It's worth something like $250,000. So, you know,
It's
not
substantial.
To be, yeah, it's certainly substantial, and particularly the amount that scientists get paid in Australia. I suppose that is. Yeah, it's a big deal.
It'd almost get you the deposit on a house in a capital city.
Yeah, there you go.
Not quite, though.
Yeah,
not quite.
I did say he's from the University of Sydney, so...
Oh, well, maybe a small bungalow.
That's right. So, as I said, he was kind of... He was a person who publicly released the genome of the SARS-CoV-2 virus. That is the virus that causes COVID-19. So I thought talk about a bit about his background. Professor Holmes, his specialty is the evolution of viruses. He recounted in an ABC News story, a little profile on him, that it's a bit ironic considering that when he was at school in the United Kingdom, his biology teacher refused to teach evolution because he was a creationist.
The biology teacher was a creationist.
Yeah, yes. Not a problem that most of us face, although it did kind of, had me fondling my days of being at high school in Queensland in the 1980s when my biology teacher, under duress, had to read out from the Book of Genesis because it was the Joe Bjelke-Peterson was premier. There was kind of a bit of a backwards view towards science and many other things. Anyway, where was I? So yeah, Eddie Holmes, in the 1990s, he got interested in the genetics of viruses. So he was interested in evolution, but he particularly got interested in viruses because they evolve rapidly. And that rapid evolution obviously can be a problem. We're seeing that with COVID-19. We've got variants arising. But it also is something that can be used to track the spread of viruses. You can look at what strains are related and how it is, how quickly it is moving. You look at where it is passed in the community, and it helps you basically work out how it's being spread and help you control the spread. So, he first started looking at things like HIV, and it was a very valuable thing in tracking the spread of HIV. But COVID-19 is, of course, the virus that we are all concerned about now. So Professor Holmes, he had kind of been involved with Wuhan before. He said that he'd been there a few times. He'd actually seen some patients with respiratory diseases in the central hospital there. He'd been to the wet market and taken photos of raccoon dogs in cages and realised that it was perhaps a possible potentially dangerous transmission site. So he's kind of aware of the whole thing. But when the virus first emerged, he got in touch with one of his colleagues, which is Professor Zhang Yongzhen from Shanghai, to talk about what was being done. Now, Zhang Yongzhen is kind of the key person in this, apart from our prize winner. He is, as I said, he's a disease expert at the Shanghai Public Health Clinical Center. On January the 3rd, he received a special metal box that had samples from Wuhan from lung samples from patients at the hospital there. And he and his colleagues got to work straight away and sequenced the genome.
Wow.
They'd done it by January the 5th. Yeah, and they noticed pretty quickly that it was similar to SARS, the virus that emerged earlier this century. And of course that was quite concerning. So he tried to raise the alarm, but the Chinese Center for Disease Control was kind of putting a kind of a lid on a lot of things there and basically forbidding people to publish any details about the virus. But Zhang was in touch with Eddie Holmes at the University of Sydney, who was pestering, saying, look, are you working on this virus? What's going on? And look, he was reluctant to share any details until he had finished the sequencing. Then he got in touch with Professor Holmes. They discussed it. They realised that it was SARS, similar to SARS. But again, Zhang was basically forbidden from releasing any information. And it was basically, he tried to talk to the officials, and it got to, I think it was January the 11th, essentially, that both, Holmes and Zhang were under pressure from the international community to release their details. And finally, Professor Holmes uploaded it to a website, virological.org, which is basically a public database of virus data. And he got Zhang to send him the data. He uploaded it straight away, And from there, it was released to the world. And it made possible things like the PCR testing that we relied on so much. And it gave a head start to the development of vaccines. So, it was like a really interesting thing that it had been kind of, again, sort of a bit of pressure not to release it. But both Zhang and Holmes realised that this was an extremely important thing to do. And if they didn't do it, that they would be doing the world a huge disservice. There has been some controversy since about any consequences for Zhang. He officially says that he was not punished by Chinese authorities for doing this. He said he actually in fact wasn't aware there was a prohibition on releasing any stuff. But his lab was shut down for a short time after, kind of the day after the data was released. But supposedly that was to increase biosafety measures, which you'd imagine would be fairly important when you were dealing with a deadly virus like this. But as I said, that's what happened, and that was kind of Professor Holmes' big contribution to the fight against COVID-19, but hasn't stopped him being targeted by a lot of people because they believe that he is central to the conspiracy to cover up the lab leak, or the theory that the virus leaked from the Wuhan lab. So I mentioned this a few weeks ago. I talked about the conspiracy theory that has been built up around what happened with that, and one of the central elements is a teleconference that took place in February 2020, where supposedly the scientists in that, had gone into it thinking that it was a human-engineered virus, and they came out of it saying, no, it's natural causes. And so the conspiracy theory is that they agreed in that telephone conference to cover it up. And Eddie Holmes was in that meeting. So he is kind of part of this conspiracy. He's kind of been, I suppose, what's the word? I don't know. There's a word there. But anyway, it's not just that. He's also been featured in numerous news articles in the News Corporation papers in Australia, particularly by journalist Sharry Markson, who, some articles claim that his work is suspect because he's collaborated with Chinese researchers. Although in these reports, they've always been careful to put the disclaimer saying, as far as we know, he's independent and they're not really questioning his work. But as a result of their reports, the conspiracy theories have grown. There have been death threats against him and a lot of kind of negative consequences. Interestingly, I did look at the News Corporation papers today. They haven't, like I mentioned, the Prime Minister's Prize for Science is the most prestigious science prize in Australia. It doesn't get a mention in the News Corporation papers, strangely enough, this year. Same thing curiously happened last year when Eddie Holmes was awarded New South Wales Scientist of the Year. That was not mentioned in any of the Murdoch papers. So, it's
that's not. That's not good reporting, is it?
No, it kind of implies that there is some sort of, I guess, agenda there or attitude. I may have missed something. I did a bit of research, but I may have missed something. But
they also might not ever report on the Prime Minister's Prizes for Science because
I did find a mention in the Courier Mail of a school teacher who won the education prizes. So they didn't entirely ignore the whole thing. They just ignored the headliner. A bit of a shout out to the other prizes because it's not just the main prize. There are a number of other prizes that are awarded. Too many to go through, but a lot of good work by people from various disciplines, people who are publicising science, people who are commercialising science, and people who are teaching science also got recognised at these awards. But look, I guess the thing there is that definitely with Eddie Holmes, his work has led to, as I said, the genome testing that we've relied on, the quick development of vaccines. These things have saved lives, so we can be thankful for that. And despite the efforts of some people to say he's done bad things, we can see his legacy, and we've all benefited from it.
It seems that one of the favourite pastimes of people around the world is discussing what they eat. And certainly in Western countries, then discussing how much of that food they burn off. Obsession about fad diets and associated exercise regimes may seem to be a reasonable topic of conversation, especially when religion and politics are off the table. Everyone can chat about their keto diet or their F45 workout without offending anyone. Well, mostly. Now, the relationship between food and human metabolism and energy consumption has often been characterised in simplistic terms. Calories in, calories out is a simplified way of explaining why people gain or lose weight. There's clearly more complexity to the equation than this. And often the word metabolism is used to explain why some people seem to be able to eat whatever they like and never gain weight, and some people seem to gain weight even when they're on the most bird-like of diets. Incidentally, birds, for their size and weight, eat a huge amount of food every day to stay alive. Flying is a very energy-intensive activity, and most birds eat around a quarter to a half of their body weight every day, just to stay alive. So
wow.
I think we need a better word for eating light. Horses only eat about 2% of their body weight a day. We've got this comparison thing all wrong completely. Eating like a horse, not eating much. Eating like a bird, you're just gorging on whatever. Now, anyway, conventional wisdom was that, sure, metabolism varies between individuals, but basically it doesn't change. We're born with our metabolism. We die with our metabolism. We're done. We've just got our metabolism. But recently, science says no. A study published in Science, the journal Science, called Daily Energy Expenditure Through the Human Life Course, has looked at the metabolism of people from all over the world, from all age groups, to find out how our metabolism changes as we age and directly measure it. And this is something that's kind of been missing with a lot of sort of theory about metabolism. What does it actually mean? As far as it goes, what they've looked at is how much energy a person uses or burns in a period of time. And the way the study was conducted is pretty ingenious. They used isotope-labelled water, in which both the oxygen and the hydrogen in the water are trackable through the person's metabolism. So the researchers can work out exactly how much energy the subject had expended in a given period. So the body splits up water into oxygen and hydrogen. The hydrogen comes out mainly in urine, but the ratio of tagged hydrogen to tagged oxygen present in the urine told them how much oxygen was lost as CO2. So as you burn energy, you produce CO2, and that's how they can actually figure out exactly how much energy a person has expended. Because
now, presumably the water is playing a role in the... we don't get energy from water, and we don't get our oxygen mostly from water either. It's my understanding.
No. But they've got calculations to actually figure out this. The ratio that they're looking for. So the numbers are all there in the paper if you want to have a look at it. But this is how they've done it. And I just think that's a pretty ingenious way to do it, to actually track directly the literal metabolism of the person, rather than just going, how much did you eat? And then how much exercise did you do? I guess we'll give you a figure, which is kind of made up. So what they've done is, this also gives them a number they can directly compare between people, and they can compare results from different studies because they all come up with the same figures, that they are directly comparable. So they've been able to look at tests of this same labelled water from 40 years worth of data, which is what they've been able to combine into a single study. And what they found was that even though there are differences in metabolism between individuals, human metabolism is the same in newborns as in fully grown adults. But at about a month old, the baby metabolism goes through the roof. It starts ramping up dramatically until the baby's metabolism is about 50% higher than that of an adult. So they use a lot more energy, and they peak at about 9 to 15 months. And then it starts to drop off again. So the metabolism starts slowing down again, but very, very slowly. And it takes until about 20 years of age for the metabolism to be back at what was a normal level that the newborn had. So, once it gets to this normal level at about 20 years old, it stays that way for about 40 years. So in other words, a 21-year-old has about the same metabolism as a 59-year-old, averaged out across all of this data. So that's pretty interesting, and that is quite different to, previous sort of assumptions about metabolism and energy consumption, all these sorts of things. So
yeah. People say, like, I could eat anything I wanted in my 20s, and now I just put on weight so easily. And
yeah, but you've got the same metabolism at 25 as you do when you're 60.
Yep.
Yeah, right.
You're using the same amount of energy. What you're consuming, that's up to you.
Right.
Presumably, you've got more money at 60 than you do when you're 25, so you can eat whatever you want.
So when you say metabolism, are you talking about just normal... I mean, because it also depends, presumably, physical activity would change, you'd imagine.
Well, what they're
throughout your lifetime.
What they're actually talking about is energy consumption. So, yeah, it would depend what you do. But there's also other studies that have shown that people who exercise more use energy more efficiently, so they don't actually burn as much or don't actually use as much energy to do exercise as people who do less exercise do when they do exercise. It's not as simple as, as we're led to believe, I think. But basically what they're saying is if you kind of, at a resting rate, your body is using the same level of energy or the same amount of energy in your 20s as in your 30s and your 40s and your 50s. But when you hit 60, it starts to drop off a lot. So the amount of energy that a person uses after 60 starts to go down quite dramatically. And people over 60 burn a lot less energy in a day than adults under that age bracket. So what does that all mean for diet? It's hard to say. This is quite kind of new research. This is only published in August in Science.
And I guess, you're thinking here about when you say what does it mean for diet, think how do we lose weight or maintain weight? I mean, the metabolism change after 60. When people are older, they often eat less anyway. So that may be explained by the fact that metabolism is slowing down. They're less hungry.
Yeah, well, that could explain that too, and it may explain why babies around the age of 9 to 15 months are just eating all the time as well. And, children and teenagers and lots of people eat all the time as well.
Babies at the age of I don't know, say, let's say randomly, 14 months, sometimes you have to really struggle to get them to eat. I don't know. It's just what I found.
Maybe, Chris, they just don't like what's on offer.
We're trying, Stu. We're trying.
Maybe they're just too fussy for their own good. But one of the things that one suggestion about the aging end of the spectrum is that energy use drops so much because the processes of repair start slowing down. So cells and tissues are not being maintained as quickly or as thoroughly as they are when you're younger, and so you're not using as much energy as you did because your body's not doing as much work in maintaining the body as it did as well. So that in itself, that energy drop, might be an indicator of aging, or it may be the cause of aging itself.
Right. So this is when you said it wasn't all good news. That's what you meant.
Well, possibly. It's also got implications for things like medication uptake and a whole bunch of other health-related things. If your cells aren't working the way they used to, then they're not going to take up drugs, so dosages and things like that may have to change as people age, which is all sort of things that people have known in various fields for a long time, but this kind of all ties it together potentially. What it does mean is that I can't use metabolism as an explanation for not feeling like I did when I was in my 20s, and I'm just going to have to find a new excuse.
And that's all we have time for on another episode of Lost in Science. Lost in Science is recorded on the lands of the Kulin Nation in the studios of 3CR Melbourne and broadcast across Australia on the Community Radio Network with the kind support of the Community Broadcasting Foundation. If you would like to get in touch with us, we would love to hear from you. You can email us at lostinsci@gmail.com. You can find us on Twitter where we are Lost in Science 1 or on Facebook where we are Lost in Science on 3CR. Or you can find us wherever you found us today again next week when Claire, Stu and Chris get lost in science.
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.